we propose Seal-3D, the first interactive pixel-level editing method and system for neural radiance fields. Seal-3D achieves instant preview, as shown on the left side, by our novel pre-training strategy. High-quality editing results can be further obtained by a short period in 1 or 2 minutes of fine-tuning. The word seal of our Seal-3D derives from the name of rubber stamp, the seal tool, of the 2D editing software Adobe Photoshop. Existing 3D editing methods, taking the mesh-based representation as an example, can change object geometry by displacing vertices corresponding to target object surface areas and object textures. Implicit neural representations, also known as NERF, have gained increasing attention as novel 3D representations with neural networks to model a 3D scene. Editing with implicit neural representations is a fundamental technique required to fully empower the representation, but how to achieve the NERF editing remains an open problem. Unlike existing explicit 3D representations which store the explicit geometry structure of objects and scenes, implicit representations use neural networks to query features of a 3D scene including geometry and color. Without explicit explainable correspondence between the visual effects and the underlying representations, editing the implicit 3D models is indirect and challenging. Further, it is difficult to locate implicit network parameters in local areas of the scene, meaning that adaptations of the network parameters may lead to undesired global changes. This results in more challenges for fine-grained editing. Previous methods, like NERF editing and Noi mesh, introduce a deformable mesh reconstructed by NERF as an editing proxy to guide object editing. However, these methods are restricted to object-level rigid transformation or are not generalizable to arbitrary out-of-distribution editing categories. To the best of our knowledge, Noi mesh is the only existing method that achieves editing at pixel level. However, it depends on the mesh scaffold, which limits the editing categories. For example, cannot create high-quality out-of-mesh geometry structures. To bridge the gap, we propose Seal-3D. Our editing framework achieves a pixel-level interactive preview speed and does not require any proxy geometry structures, allowing it to be more direct and extensive. In summary, our contributions are as follows. Firstly, we propose the first interactive pixel-level editing method and system for neural radiance fields, which exemplifies fine-grained multiple types of editing. Secondly, a mesh-free proxy function is proposed to establish the correspondence between the explicit editing instructions and the update of implicit network parameters, and a teacher-student distillation strategy is proposed to update the parameters. Thirdly, a two-stage training strategy is proposed to enable instant preview of local fine-grained editing without contaminating the global 3D scenes. Our editing workflow starts with the proxy function, which maps the query points and ray directions according to user-specified editing rules. Then a NERF-to-NERF teacher-student distillation framework follows, where a teacher model with editing mapping rules of geometry and color supervises the training of a student model. In an extra pre-training stage, the points, ray directions, and inferred ground truth inside edit space from the teacher model are sampled, computed, and cached previously. Only parameters with locality are updated and the parameters causing global changes are frozen. After the pre-training stage, the student model is fine-tuned with a global training stage. Here are our results and the GUI demo. For more details, please visit our project page. Thanks for your time.